Ready to dive into some seriously challenging math problems.
Always up for a challenge, especially when it involves flexing those brain muscles.
We're tackling the Australian Mathematics Competition, or AMC for short.
Oh, the AMC, aka the stuff mathematical legends are made of.
Exactly. And we've got a stack of excerpts from Problem Solving via the AMC to guide us. It's a book that doesn't mess around, pulling together some of the toughest problems from past competitions.
Sounds intense. What's the game plan for this deep dive?
We're dissecting some of the trickiest problem categories, the ones that make you really stop and think.
And hopefully by the end, we'll have picked up some clever tactics to crack the code, so to speak.
You got it. But before we get our hands dirty with equations and whatnot, the book's foreword had something important to say about the AMC. It's not about memorizing formulas like crazy.
It's about thinking differently, right? Finding those aha moments when a solution clicks.
Exactly. It's about pushing your mathematical boundaries and seeing what you're capable of.
And judging by the sheer number of participants, over 500,000 back in '92, it's safe to say the AMC has struck a chord.
500,000. Wow. That's incredible. It really shows you how many people are drawn to this kind of challenge. And here's the thing. You don't need to be some kind of math genius to get something out of it.
Right. The book and the competition itself caters to a pretty wide range of math enthusiasts. They even say from good average students all the way to those who, well, practically dream in equations.
So there's room for everyone at the problem-solving table. But how does the competition actually play out? How's it structured?
All right, picture this. 3 divisions, junior, intermediate, and senior. Each division gets the same 30 multiple choice questions.
So far, so good.
But here's the catch name. The questions get progressively harder. You might breeze through the first few feeling super confident,
Been there.
and then bam, you hit a wall.
Yeah.
A real brain teaser that makes you go, wait, how do I even approach this?
It's like a strategic blend of encouragement and, oh, you thought it was going to be that easy.
Precisely. It's designed to test your problem-solving skills, not just whether you can recall a formula from memory.
Speaking of problem solving, let's talk about a type of problem that often pops up in these competitions, Diophantine equations.
Ah, yes, those. Always a good time.
Now, I'll admit, whenever I hear Diophantine equations, I get a little nervous. What exactly are they?
Well, the book actually kicks off this section with a little story. A great way to pique your interest, right?
Yeah.
It's about this mathematician named Diophantus, who lived around, around the year 275.
Okay.
And get this, we actually learn about his life through a Diophantine equation.
It's like mathematical storytelling. I love it. But for those of us who might not be familiar, what makes a Diophantine equation unique? What is it?
It's simpler than it sounds, really. It's basically an equation where you're only looking for whole number solutions.
Whole numbers meaning.
Like 1, 2, 3, and so on. No fractions, no decimals allowed in the solution. And that little restriction right there, that's what trips people up.
Because it's not just about finding an answer, it's about finding the right kind of answer.
Exactly. To illustrate this, the book throws this really interesting money problem at us. Imagine trying to make $5
$5, okay.
using only Australian coins. So we've got our 50-cent pieces, our 20-cent pieces, and our 10-cent pieces.
All right, sounds doable so far.
But here's the twist. You have to use more 50-cent coins than 10-cent coins.
Oh, okay. So suddenly it's not as straightforward as just grabbing any combination of coins. Now we have to be strategic.
Exactly. And that, my friend, is what bumps this problem into Diophantine territory. We're not just looking for any solution. We're looking for a very specific type of solution. Whole number of each coin type that meets this extra condition.
So how do we even begin to tackle something like this? Do we need some crazy, complicated formula?
You might be surprised to hear that we don't need some ancient mathematical secret. The book actually demonstrates a solution using something called the systematic listing method.
Systematic listing, as in just writing out all the possibilities.
Well, not exactly just writing them out, more like strategically organizing them. And it's a really good example of how a little bit of logic and organization can go a long way, even without busting out any fancy formulas.
So you're telling me you don't need to be a math whiz to solve these AMC problems, just organized and, well, maybe a little bit clever.
Cleverness definitely helps. But let's see how clever those who actually took the AMC were. Want to hear the percentages of students who correctly solved this coin puzzle?
Hit me with those stats.
Brace yourself. They're lower than you might think. Only 22% of junior division students got it right.
22%? Wow, that's pretty low.
It is. Then we've got 28% for the intermediate division.
Still pretty low.
And even for the senior division, only 45% got it.
Wow, less than half. I guess those numbers really drive home the point that these AMC problems, they're not your average math questions.
Nope, they're in a whole different league. They require a different way of thinking, moving away from that rote memorization and towards, well, creative problem solving.
It's like they're testing your ability to think on your feet, mathematically speaking.
Exactly.
All right, so we've dipped our toes into the world of Diophantine equations. Up for tackling another big one.
Bring it on.
All right, then, let's talk about counting techniques. Sounds simple enough, right?
Deceptively simple.
Because I have a feeling there's a lot more to it than just, counting from 1 to 10.
Oh, absolutely. We're not talking basic counting here. We're talking about understanding the underlying strategies and principles that help us count efficiently and accurately, especially when things get a bit more, shall we say, complicated.
So spill the beans. What's the secret sauce to these counting techniques? What's the book highlight?
It's all about something called systematic counting. And no, it's not about counting on your fingers and toes.
Thank goodness for that. I might run out of digits.
It's about finding those elegant strategies to organize possibilities and avoid those brute force methods, especially when we're dealing with larger numbers or trickier arrangements.
So working smarter, not harder. That's a philosophy I can get behind.
Got an example to bring this to life?
You bet. Let's say we need to create some labels. Each label has one letter followed by one digit. Like A0, A1, all the way to Z9. How many unique combinations are possible?
Okay, let me think. We've got 26 letters in the alphabet and then 10 digits from 0 to 9. So is it as simple as multiplying 26 by 10?
Boom! You nailed it. That's the multiplication principle in action. Instead of listing out every single possibility, which would take forever, we can use this principle to zip right to the answer, 260.
See? Efficiency at its finest. I can see why understanding these principles would be a game changer for those AMC problems. But you did mention earlier that sometimes listing out the possibilities is the way to go. When would that be?
Right, because math is all about having a toolbox of strategies, right? Sometimes the most straightforward approach is the best, especially if you're working with a smaller set of possibilities or if you need a visual aid to wrap your head around the problem. So it's all about picking the right tool for the job. Before we jump into some more of these brain-bending examples, can you clear something up for me? What's the difference between permutations and combinations?
Ah, yes. The classic permutation versus combination conundrum. A lot of people get tripped up by this.
Including me. Lay it on me.
Let's go back to our letter-digit example. In a permutation, the order matters. So AB would be different from BA. But in a combination, we don't care about the order. AB and BA are the same thing.
So sometimes order matters, sometimes it doesn't. It's like the mathematical version of it depends.
Exactly. And figuring out what the problem is, asking whether order matters or not, that's a crucial first step. Now, are you ready to see how these principles play out in some real AMC-style problems?
Hit me with your best shot. I'm ready to put these counting techniques to the test.
Okay, how about this? Imagine a street where the houses have odd numbers on one side and even numbers on the other. Simple enough, right?
So far, so good.
Now, let's say there's a house that's number 137 when you start counting from one end of the street. But if you start counting from the other end, that same house is number 85. The question is, how many houses are on that side of the street?
Ooh, that's a good one. I can already feel my brain trying to visualize this street and figure out the pattern.
It's a great example of how a problem can seem simple at first glance, but there's a bit more to it than meets the eye.
Because it's not immediately obvious how to solve it?
Right. The key here is recognizing that those house numbers, they form what we call an arithmetic sequence.
An arithmetic sequence. Okay, you're going to have to refresh my memory on that one.
Basically, it's a sequence where the difference between each term is constant. So in this case, we're adding 2 to get from one house number to the next.
Right, because we're only looking at the odd numbers on one side of the street.
And once you recognize that pattern, you can use the properties of arithmetic sequences to figure out the total number of houses without having to count them one by one.
It's elegant, isn't it? Using a bit of number theory to solve a real-world problem. It's a good reminder that these competitions, they're not just about crunching numbers in a vacuum. It's about understanding patterns and relationships and using those to your advantage. Okay, give me another one.
You asked for it. How about this? How many four-digit numbers are there, where all the digits are different, none of them are zero, and they all add up to 12?
Okay, now we're talking. This feels like one of those combination lock problems. It's not just about picking any four digits. There are rules, conditions.
Exactly. You can't just randomly throw digits together and hope for the best. This is where those systematic counting techniques we talked about earlier come in handy.
So we need a game plan. Where do we even begin?
We need a systematic approach. You can start by listing out all the possible sets of four different digits that add up to 12.
Okay, so like 1, 2, 3, and 6 would be one set.
Exactly. But remember, we have those other conditions.
Right.
The digits have to be different, and we can't use zero. So once you've listed out all the sets, you then go through and eliminate any sets that don't fit the criteria.
It's a multi-step process, a real test of your ability to stay organized and think critically.
Precisely. And it highlights how these problems often require a combination of strategies. You might use the multiplication principle in one step, then systematic listing in another, and maybe even some logical deduction along the way. And speaking of strategies, the book also throws something else into the mix. Derangements.
Derangements. Okay, that sounds a little intimidating. What are we talking about here?
Think of it this way. Imagine you have four letters and four envelopes.
Okay, I'm visualizing.
A derangement asks, in how many ways can you put those letters into the envelope so that none of them end up in the correct envelope?
Oh, wow. I think we've all been there with snail mail. Maybe not on that scale, but still. Misplacing one letter is bad enough. Mixing up all four, that's next level organizational chaos.
It's a classic mathematical puzzle. And the answer might surprise you. There are only 9 ways to do that, to arrange those four letters so that none of them are in the right envelope.
Wait, really? Only 9? I would thought it'd be way more than that.
It does seem counterintuitive, right? But that's the beauty of math. It often challenges our assumptions and shows us that things aren't always as they appear.
It's like a magic trick, but with numbers instead of rabbits and hats.
And of course, like most things in math, there's a formula for it. It helps you calculate derangements for any number of items without having to go through the painstaking process of listing out every possibility.
There's always a formula, isn't there? Mathematicians love their formulas. But you know what I really love about these AMC problems is how they connect to those, well, kind of everyday scenarios. We've got money puzzles, we've got house numbers, we've got misplaced letters. It shows how math is woven into so many aspects of life, even if we don't always realize it.
Absolutely, it's all connected. And believe it or not, we've only just scratched the surface of what the book covers. It goes deep into geometry, too, exploring a whole other set of problem-solving tools.
All right, let's talk geometry then. Hit me with a geometric brain teaser. What's hiding in the geometry section of the book?
Get ready for this one. Picture a cube, and some of its faces are painted. Now, imagine we break this cube apart into smaller cubes. If we end up with 45 smaller cubes that have no paint on them at all, how many faces of that original larger cube were painted?
Oh, that's good. That one's got me thinking. I can already picture people listening going, wait, hold on, I need a diagram.
It definitely calls for some of that spatial reasoning we talked about, right?
For sure. It's not just about crunching numbers. You've got to visualize how those smaller cubes fit together to build that bigger cube. And then how does the paint on the outside affect which of the smaller cubes end up with no paint? It really drives home the point that these AMC problems, they're not just about memorizing formulas or going through the motions. They force you to think creatively, to look at things from different perspectives.
All about problem solving, about finding those elegant solutions. And that's what the AMC in this book, Problem Solving via the AMC, really encouraged, that spirit of exploration, that willingness to dive into a challenge head first. It's a valuable resource for anyone, really, whether you're a math competition pro or just someone who loves good brain workout.
I couldn't agree more. It's been amazing to take a closer look at the kinds of problems that make the AMC so unique, so challenging. It's not just about getting the right answer. It's about the journey, about those aha moments when a solution clicks into place.
It's about pushing those boundaries and realizing that math can be a lot more fun and engaging than some people might think.
Absolutely. So to all our listeners out there, whether you're a seasoned mathlete or just starting to explore the world of math competitions, embrace those challenges. Don't shy away from them. Experiment, try different approaches, and most importantly, have fun with it.
You never know. You might surprise yourself with the creative solutions you come up with. After all, that spirit of exploration, that's what math is all about.